See. Yes. See.
The train travels at constant high speed until it approaches the next station. There is a sudden drop in speed when it enters the station till it finally stops.
See here what you have observed. First train started. If you plot the motion of this train, and if we plot a graph between time and velocity. So from the station here, it started, starting 0 velocity, then it increased its speed. That means velocity increases. First 0, 10, equal intervals it is changing. Time is given 1 minute, 1, 2, 3, 4. See, equal interval time 10, 10, like that it is increasing. So velocity changes are equal in equal intervals of time. Velocity changes are equal see in 1 second how much change in velocity? 10, suppose it is meter per second, 10 meter per second velocity is changing. Next 1 second also 10 meter per second is increasing, like that 0, then it becomes 10, 20, 30, 40, equal intervals. So equal change in velocity is happening. Change in velocities are equal in equal intervals of time. So we call it as what acceleration, children? Change in velocities are equal in equal intervals of time. What is the name of? Uniform acceleration. Uniform acceleration. So here the train is uniformly accelerated. Then it moves with a constant velocity when no other obstacles are there in its path. So it moved with a constant velocity. So for example, how much it is? Suppose this is 50 meter per second, constant velocity. It moved up to 15 seconds. It moved with a constant velocity. So this is the graph for constant velocity. Velocity time graph. So velocity is constant here. Then what happened, children? What this part of the curve shows? Velocity is
decreases.
decreases. Velocity is decreasing from 50 to suddenly decreased, but that also is uniform. 50, then 16 seconds it is 30, 50, 40, 30, like that it is decreasing. Decrease also uniform. Then it becomes 0 here. It reached the station. So its velocity decreased and at last it becomes 0. So here also the change in velocities are equal intervals of time, but what is the difference? Velocity is decreasing here. Velocity decreasing, that we call as what, children? Decrease in velocity is called as retardation. You have studied that, no? Retardation, negative acceleration.
Yes.
Okay. Okay. Children, I will bring some water. Okay, please. Okay. Okay, children. So now we are studying about acceleration. Acceleration can be acceleration means change in rate of change of velocity That means change in velocity by time interval. Here, in the case of motion of a train or a motion of a car, we can see initially start from rest and it increases its velocity. But in our roads and all, we cannot have uniform acceleration. But in this case, we have drawn uniform acceleration. Uniform acceleration means if the change in velocities are equal in equal intervals of time, that is uniform acceleration. So here we can see a straight line inclined to time axis. That is, velocity is increasing with time, increasing. And then it moves with a constant velocity for certain time interval, moves with a constant velocity, no change in velocity. Then it decreases and becomes zero. So just by seeing the graph, you should be able to tell this is positive acceleration. This is no acceleration, zero acceleration. Constant velocity means no acceleration is there. Constant velocity. Uniform velocity. When a body moves with uniform velocity, acceleration is zero. And this part of the curve graph shows that negative acceleration, downwards. Line, that means inclined downwards it is upwards. The graph is inclined to time axis upwards. This is inclined to time axis but downwards. And this is a straight line parallel to time axis, that is constant velocity. Okay. So just by seeing the graph, you should be able to tell the motion of the vehicle. Understand? Okay. Then from the velocity time graph, how will you find the acceleration? Let us see that.
The first and the last part of this train's motion has high positive acceleration and very high negative acceleration or retardation. Acceleration of a body is the rate of change of its velocity with time. The average acceleration A dash is defined as the change of velocity divided by time.
See children, average in this, what type of motion is this? Uniform acceleration or non-uniform acceleration, children?
Non-uniform.
Non-uniform. Because, what is the reason? What is the reason?
Because it is a curved line.
Curved line, correct. This is a curved line. So this is non-uniform acceleration. So initially change in velocities are not equal in equal intervals of time. So average acceleration, how will you find? With different velocity the body is moving. Vehicle is moving with different velocity. And how will you find the average acceleration during its journey? So from this time to 5 to 8 seconds, what is the average acceleration? For finding that, you just take 2 points and join those 2 points with a straight line. And then draw perpendiculars to both the axes. Perpendiculars. Then V2 minus V1. You find out tan theta will give the slope of this line. Tan theta give the slope of this line. So tan theta means opposite side V2 minus V1 by adjacent side T2 minus T1. T2 minus T1, how will you find? 8 minus 5. 8 minus 5, 3. And here, suppose 60 and this is 20. 60 minus 20, yes, 60 minus 20, 30. So 30 by how much children? 30 by? What is the difference? 5 and 8?
3.
About 30. 30 അല്ലേ 44.
Teacher 40 അല്ലേ?
40. Here it is 40. 60 ആണിത് അല്ലേ? 60 minus 20, 40. 40 by how much? 40 by how much?
3.
3. Like that. That way you can get the acceleration. Okay. 40 by 3 meter per second square. Change in velocity. Velocity is unit. Velocity is unit. Meter per second divided by second. So what is the unit of acceleration?
Per second square.
Meter per second square. Okay. So that way you can find out the average. See, a bar is put on A, average acceleration. So from the VT graph, how will you find average acceleration? What is the answer for that? From the VT graph, how will you find average acceleration? Tell. What we have found? Slope of the line. From the VT graph, how will you find acceleration? By finding the slope
Slope
of that
the graph.
slope of the graph. Slope. You just take any 2 points and join that with a line and find the slope of that line. That will give the average acceleration, change in velocity by time. Okay.
v2 and v1 are instantaneous velocities at times t2 and t1. The SI unit of acceleration is meter per second square. On the VT,
See, V2 minus V1 by T2 minus T1. It can also be written as delta V. Delta V means change in velocity. Delta T means change in time interval. How much time it has taken to increase its velocity from V1 to V2. Time interval taken for that change in velocity. Time interval taken for that change in velocity. Delta V by delta T, that is acceleration, average acceleration. Don't tell acceleration simply, because simply if we tell acceleration, that is instantaneous acceleration. If we put a bar over it, that will give only average acceleration. So average acceleration expression is delta V by delta T, but instantaneous acceleration, it is different.
graph. The average acceleration is represented by the slope of the line joining the points v1, t1 and v2, t2. Just as we defined instantaneous velocity, we can similarly define instantaneous acceleration. On the VT graph, instantaneous acceleration at any point on the curve is represented by the slope of the tangent drawn at that point.
See, last class I have explained this instantaneous velocity, how at a point, velocity at an instant, how we found from the xt graph, that is by drawing tangent to that point. Tangent, draw a tangent and then find the slope of that tangent, and that will give the instantaneous velocity, that is xt graph. From xt graph we find instantaneous velocity. This is VT graph. Velocity and time you can see. Velocity along y-axis, time along x-axis. So this is the VT graph. VT graph. And from VT graph, how will you find acceleration? Average acceleration we know, V2 minus V1 by T2 minus T1. Instantaneous acceleration, we have to give the time limit. As I explained, in the case of instantaneous velocity, we have given the limit to time when delta t tends to 0. Delta x by delta t, that is instantaneous velocity. Similarly, how will you define, children? Similarly, how will you define instantaneous acceleration? Anyone? Similarly, as we have done for instantaneous velocity, how will you define instantaneous acceleration? Anyone, children, please? This is the delta V by delta T. Then what we have to give the limit? For what we have to give the limit?
Time interval.
Time interval. What limit we have to give?
Tends to 0.
Correct. When time interval tends to 0, then complete it. When time interval tends to 0, expression, what you have to tell? Delta V by delta T. Time interval tends to 0, delta V by delta T gives dV by dt, that is instantaneous acceleration. Time interval tends to 0, delta V by delta T, this is delta V actually, delta V by delta T equal to dV by dt, first derivative of velocity. What is first derivative of x, children? dx by dt, what is it? Last class we have seen what is dx by dt?
Instantaneous velocity.
Instantaneous velocity. What is dv by dt? dv by dt is this. What is this?
Instantaneous acceleration.
Acceleration, correct. dv by dt. dv by dt is acceleration. dx by dt is instantaneous velocity. That is the difference in expression. So, two expressions we have studied. One is for instantaneous velocity, and here now we study instantaneous acceleration. It is limit delta t tend to 0, delta v by delta t, or it is written as dv by dt, first derivative of velocity with respect to time. First derivative of velocity with respect to time. In the language of calculus, it is first derivative of velocity with respect to time, and we have to do problems based on this.
Like velocity, acceleration is also a vector with both magnitude and direction. The acceleration of a body can change with either a change in the magnitude of its velocity or change in the direction of its velocity, or both. In rectilinear motion, we have only two directions of motion, positive and negative. Therefore, we have two types of velocities, positive and negative. Similarly, we have two types of acceleration, positive and negative. Formulating a proper and consistent sign convention for acceleration is very important. Let's understand what constitutes positive and negative acceleration. Zero acceleration stands for uniform velocity. That is, the velocity does not change with time. Let us consider cases where acceleration is positive. Case 1. Let us consider a body, say, a car moving along a straight line. That is, from point A to B, with increasing magnitude of velocity. The body is said to be moving in the positive direction. Here, delta V is positive and direction of motion is positive.
Listen children, you have seen a car started from A and reached the point B, and it is increasing its velocity. Acceleration is there, and it is moving this direction. We take positive towards right. Towards right we take positive direction, and increase velocity is also increasing. Both are positive. Velocity is increasing and body is moving in the positive direction. So it is positive acceleration. So body is accelerated, velocities are increasing, initial velocity is less than final velocity. So velocity increase, we can change in velocity, that is positive. Velocity is increasing, final velocity is greater than initial velocity. Velocity increases, accelerated motion, and it is moving in the positive direction. So that is positive acceleration. Okay.
Therefore, with these two values being positive, acceleration is also positive. Case 2. In this case, the car is moving in a negative direction. That is, from point B to A, with a decrease in the magnitude of velocity. Here, delta V is negative and the direction of motion is also negative. Since the product of two negative values is positive, acceleration in this case is also positive. Let's now consider cases.
See children, here body moved from the B to A, negative direction, and velocity is decreasing. So final velocity, suppose for example it becomes 0. Started with a velocity, for example, 20 meters per second, and it becomes 0, 20 kilometers per hour, and it becomes 0. So moving in negative direction and velocity decreased. So delta V, change in velocity, is negative. For example, 70, here 70 is there, here it is 0, velocity is decreasing. Final minus initial, that will be negative. Final velocity minus initial velocity, that will be negative. Delta V is negative. And direction of motion is negative. So both are negative. So acceleration is positive. Both are negative. So acceleration is negative. That is the sign convention used in acceleration. Okay, both negative. Earlier time, both positive. And here, second case, body moved towards left, velocity is decreasing. So we call it is negative acceleration.
Where acceleration is negative. Case 1. Now consider the car moving in a positive direction.
A lot of times I used to get very nervous speaking to overseas clients because I couldn't understand what they were.
Okay.
That is, from A to B, with a decrease in the magnitude of velocity. Here, delta V is negative and direction of motion is positive. Since the product of a negative and a positive value is negative, the acceleration in this case is negative.
If the velocity is decreasing, body is moving A to B, but velocity decreasing, for example, initially 70, suddenly applied brake and it reduced to 0. Reduced to 0. Initially 70. Velocity decreased to 0, but body is moving towards right. Direction of motion is positive, but velocity decreased. So positive and negative comes. So what happened? It will be negative acceleration. That is the way to tell the acceleration. Body is moving in the positive direction, but velocity is decreasing. In that case, it is negative acceleration.
Case 2. In this case, the car is moving in a negative direction. That is, from B to A, with an increase in the magnitude of velocity. Here, delta V is positive and direction of motion is negative.
So what will be acceleration? What will be acceleration in this case, children? Velocity increased, 0 to, for example, 60. Direction of motion is negative. So what will be acceleration? Children?
Negative.
Negative. It will be negative. Product of positive and negative will be negative. Okay.
Positive and a negative value is negative. The acceleration in this case is also negative.
Okay,
To
children.
decide whether acceleration is positive or negative, the terms retardation or deceleration are confusing while solving problems. Here is an easy way to get the sign convention for acceleration right. In the 4 cases we have just studied with respect to points A and B between which the body traverses, let us fix the velocities of the body at these points as V at A and V dash at B. The 4 cases are tabulated. If the origin and direction of motion are discarded, we are left with the type of acceleration and the relation between the velocities at 2 points. If V and V dash are taken as the initial and final velocities in any given problem, then if V is less than V dash, then acceleration is positive.
See, this is the sign convention we take doing problems. V means initial velocity, 0. And it reached to 60 km per hour. Final velocity increased, 0. Increased to 60 km. Car start from rest and increased speed to 60 km per hour. So final velocity is more here. And P dash is more. Initial velocity is less. So we take positive acceleration. That is positive acceleration considered. And what is negative acceleration?
Else negative. Let us see what the xt graphs for positive, negative, and zero acceleration look like. The xt graph for motion with positive acceleration curves upward. For negative acceleration, it curves downward.
See, sometimes question will be there. Draw the position time graph for positive acceleration. See, this is not velocity time graph. We are actually we are studying about acceleration. We plotted velocity time graph. We found the slope to get acceleration. Finding the slope of the VT graph, we get the acceleration. That and all we have seen. But if you are asked to plot an xt graph, position time graph for a positive acceleration, it will be parabola upwards, positive. So you have to just draw the graph, xt graph, x along y-axis, t along x-axis, and the curve upwards. Curve upward will be the positive acceleration. Curve downward will be negative acceleration. And if it is a straight line, what will be the nature of motion, children? Parallel to time axis. If I plot a xt graph is plotted with a straight line parallel to time axis, sorry, inclined to time axis, I'll show the graph.
For zero acceleration, it is an inclined line.
This is negative,
Let us
and this is negative acceleration. Next.
see what the VT graphs for all four cases explained earlier look like.
See this graph. What can you say about this velocity? Xt graph is a straight line inclined to time axis. What is the velocity, children? Mohammed Nidal, tell. Xt graph is a straight line inclined to time axis. What velocity body is moving? Midul. 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 No answer. Mohammed Nihal. Nihal. Nihal also not answering. Parthiv, what type of motion is this? Xt graph is a straight line inclined to time axis. Is it accelerated motion or uniform motion? Options I will give. Ayush. Ayush not answering. I will record. You are not answering here for any question. So internal marks you will not get, children. Fatima, what type of motion is this? Fatima Shasha? You will not get internal mark. If you are not answering my question, internal mark you will not get, children. Deeba Suresh, what type of motion is this? Straight line inclined to time axis. Tell, Deeba. Accelerated motion or uniform motion? Simple question. Very simple question. Answer, please tell. Whether it is a wrong or right, you please tell the answer. No problem if it is wrong. No problem. You are sitting with your friends and I am here. So what is the question of Shai and all? If you know, you tell. Asna, what type of motion is this? Asna. 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 No one is answering. Lena, what type of motion is this?
Uniform motion.
Uniform motion, correct. So this is uniform motion, not accelerated motion. Uniform motion acceleration will be 0. Understand? So xt graph curve upwards, parabola upwards, positive acceleration, parabola downwards, negative acceleration, and a straight line inclined to time axis, acceleration is 0.